NASA's Perseverance rover just spotted what looks like a turtle peeking from its shell on Mars. It's real. It's weird. And no, it's not proof of space reptiles. Tonight, how this image was captured, why our brains see animals in Martian rocks, and what these strange shapes actually tell us about Mars's ancient environment. On Sunday, August 31st, Perseverance used a close-up instrument called Sherlock that's scanning habitable environments with Raman and luminescence for organics and chemicals to image a small rock that just happens to resemble a turtle stretching its head out of a shell. This isn't a zoom from far away. Sherlock rides on the rover's robotic arm to inspect textures and chemistry from just inches away. This turtle joins a long list of Mars illusions. Last month, a rock that looked like a weathered conquistador helmet. Back in March, a sphere-dotted outcrop the team nicknamed St. Paul's Bay. Famous example? The face on Mars from the 1970s. Just shadows on a mesa. The brain's doing what it's wired to do. Find familiar patterns, a phenomenon called pareidolia. Here's the important bit. Weird shapes are a clue, not a punchline. The turtle shell curvature, the helmet spire, the peppered bay, they're all carved by wind, sandblasting, temperature swings, and ancient water processes. In Jezero Crater, where Perseverance landed in February 2021, scientists are piecing together a timeline. A lake, a river delta, cycles of flooding and drying, then eons of erosion. Each odd rock is a data point about how Mars changed. Perseverance is a rolling lab, Mastcam Z, zoom cameras for landscapes, layering, and context. Sherlock, close-ups with lasers and UV to probe organics and minerals. Pixel, X-ray spectrometer to map elements in tiny rock areas. Supercam, zaps distant targets with laser spectroscopy. Sample caching, cores rock seals it and stores it for a future Mars sample return. Does the turtle mean life? No, it means texture. The way edges are rounded suggests abrasion. The protruding neck is likely a harder vein or a chunk with different cement binding. On Mars, subtle differences in grain size or mineral glue can make one piece erode slower than its neighbor. Voila, a turtle illusion. The real win is we get a close-up of laminations, pits, veins, and coatings that tell geologists how fluids once moved through this rock. Jezero was picked because it's an ancient lake and river delta, prime real estate for preserving biosignatures if Mars ever hosted microbes. Fine-grained sediments can trap organics. Mineral veins can record water chemistry. When Sherlock and Pixel scan these textures, researchers test hypotheses. Was the water acidic or neutral? Were there repeated wet-dry cycles that could drive prebiotic chemistry? Perseverance has logged 23+ miles across the crater, and this turtle was spotted on Sol 1610. That's the 1610th Martian day of the mission. Each stop, the team trades speed for science: imaging, zapping, drilling, and caching. Not every photogenic rock gets a core, but the patterns across many rocks are what build the story of water, climate, and habitability. Every time a rock goes viral, scientists get two things: a chance to teach pareidolia and a window to explain how we actually decode Mars, chemistry plus context. The outreach win matters. It keeps the public engaged while teams do slower, methodical work like mineral mapping, spectra analysis, and sample selection. The turtle gets clicks, the chemistry gets answers. So yes, it looks like a turtle, but the real marvel is the story locked inside the stone, written by wind, water, and time on a world we're still learning to read. Perseverance keeps rolling, scanning, and sampling, and every odd shape we stop for helps answer the biggest question of all: could Mars have ever supported life? If you loved this breakdown, smash like for the science of seeing, drop a comment with the weirdest space illusion you've spotted, and subscribe. We'll keep following Perseverance's trail, one rock at a time.